Let's have a quick overview about GitHub Actions. So let's assume an organization has already decided to use GitHub as their code repository and is in search of an automation solution. So there are numerous tools available in the market to automate CI/CD pipelines. Nevertheless, given the organization's commitment to GitHub as the code repository, so let's explore how GitHub Actions offer the automation capabilities. So what is GitHub Actions? GitHub Actions is a powerful and flexible automation platform provided by GitHub. It allows developers to automate tasks directly from their repositories. You can quickly create workflows to implement a CI/CD pipeline that build, test on every pull request, and deploy merged pull request to the production right beside your codebase. Out of the box, these steps can be executed in different operating systems like Ubuntu, Windows, and macOS. And few advantages of GitHub Actions is that GitHub manages the infrastructure for you, which includes setting up the servers, scaling the resources, and managing the environments for your workflows. Your task is to write workflow configurations in YAML files, and GitHub Action handles the rest of the tasks. This includes executing the tasks within a virtual machine, caching necessary dependencies, and also providing reports on the outcomes. Finally, this automation also helps you streamline development, reduce manual errors, and increase the efficiency of your software development workflow. So, is GitHub Actions solely used for automating CI/CD pipelines for building, testing, and releasing code? And the answer is no. GitHub Actions goes beyond just CI/CD and lets you run workflows when other events happen in the repository. It can be used for automating all kinds of repository actions by listening to events such as push events, issues, pull request, GitHub registry packager events, or whenever an issue or a pull request gets updated. And these are just few of the trigger points. So we have a lot more other trigger points as well. So for instance, let's consider a scenario where a project contributor initiated a new pull request, and by utilizing GitHub Actions, you can automatically post informative comments, apply labels, assign contributors, and even add reviewers to assess and approve the proposed changes. These automation capabilities aren't limited solely to the pull request. You can employ similar actions for various other GitHub events as well. So now that we established the fundamentals of GitHub Actions, let's understand how and where these tasks are executed. The core component of GitHub Actions is a workflow. A workflow is an automated process capable of executing one or more tasks. These workflows are defined using YAML files and are located in the .github/workflows directory within your repositories. A repository can have multiple workflows, each of which runs in response to a specific event occurring in your repository. For instance, in this example, a simple event like pushing code to the repository triggers the workflow. And within each workflow, you define one or more jobs. A job consists of a series of individual steps which are executed on a runner. And a runner is nothing but a virtual machine which is responsible for executing your workflows upon triggering. So GitHub automatically provisions runners for each job based on the runs on configuration specified at the job level. In this example, there is a job named unit testing that runs 3 different machines. So it runs on Windows, Ubuntu, and macOS. So consequently, GitHub Actions will provision 3 virtual machines for this job, and these VMs are known as GitHub hosted runners. So GitHub is going to host Linux and Windows runner on Microsoft Azure platform, while macOS runners are hosted in GitHub's own macOS cloud. And in this particular workflow example, all the runners are provisioned and operated in parallel. And after the runners are up and running, they start executing the steps which are defined within the job. So in this example workflow, there are 3 steps, and the steps are executed in series. First, the runners will clone the repository locally on the virtual machine. Then they proceed to install Node.js and set up the necessary environment. And lastly, the Node.js tests are executed. So these same steps are executed on all the 3 runners concurrently. And consequently, if one runner completes all the step executions, it will be marked as successful, even if the other runners are still in progress of executing their remaining steps. The workflow as a whole is marked as successful only once all these 3 runners have completed the task successfully. So during or after the job execution, you can access the logs, outputs, and any artifacts for each step via the GitHub user interface. So this information is often received from the runners where the jobs gets executed. So within the GitHub repository, so we can simply navigate to the Actions tab to inspect the logs and the artifacts. So here, you will find that the unit testing job has been executed on 3 different machines, and you can review the logs of each of them individually. So this is going to allow for detailed debugging of the workflow progress and also to check the results. And if the job generates any artifacts, you can access and download them from this page as well. So GitHub Action provides a convenient interface for managing and retrieving any artifacts produced during this workflow's execution, and it's going to enhance the overall visibility and the usability of your automated processes. So now that we talked about runners, so let's understand the types of runners. So we have 2 types of runners, GitHub hosted runners and the self-hosted runners. So let's try to explore the key differences between them. So the GitHub hosted runners, as mentioned in the name, are hosted and maintained by GitHub. So GitHub is going to provide a set of virtual machines with various configurations, including different operating systems and software environments. So you don't need to worry about managing the infrastructure of these runners. And whereas self-hosted runners are going to be set up and run on your own infrastructure, such as your own servers, virtual machines, or even cloud. So you'll be having the full control over the environment, but you're also responsible for setting up and maintaining these runners. The second one is about the instances. So when you talk about the GitHub hosted runners, so they by default provide a new clean instance for each and every job execution. And in the self-hosted runner, we can run multiple jobs on the same machine. And the third point is, within the GitHub hosted runners, you cannot customize the runners beyond selecting the type of the runner. You can, such as Windows, Ubuntu, and macOS, but we cannot install additional softwares or make system level changes. So whereas in the self-hosted runner, you have the complete control over the self-hosted runner's environment. You can install any required software, configure the runner to your needs, and even use it to run workflows that require specific hardware or software configurations. And talking about the pricing perspective, so GitHub hosted runners are provided as part of your GitHub subscription. So they are usage limits. So if you exceed the usage limits, you may incur additional charges. And whereas in the self-hosted runner, you bear the cost of maintaining and operating your own infrastructure. So choosing between the GitHub hosted runners and the self-hosted runners depends on factors like your workflow requirements, security considerations, and infrastructure capabilities. So each of it has its own advantages, and the choice should always align with your specific needs. So in this video, we provided a brief overview of workflows, jobs, steps, and runners. Let's explore the core components of GitHub Actions. GitHub Actions consist of 3 key components, which are the workflow, jobs, and steps. So let's take an example and understand them. A workflow is an automated process capable of executing one or more jobs. It is widely used in software development process, from building and testing code to deployed to various environments. These workflows are defined using YAML files and are located within your repository. A repository can have multiple workflows, each of which runs in response to a specific event occurring in your repository. To uniquely identify workflows, each workflow can also have an optional name keyword. This name will be visible in the Actions tab of the GitHub repository. In this example, the workflow is triggered for a push event, and we will talk more about triggers and events in a later session. The next core component is a job. So jobs are the building blocks of a workflow, and you can have one or more jobs within a single workflow. Each job is again associated with a runner. It could be a GitHub hosted or a self-hosted runner. So we use the runs on attribute to specify, the runner configurations. And we will talk more about runners in a later scenario. So here on the left side, as you can see that we only have one job, and it will run on the Ubuntu latest, runner. The next component is steps. So steps in GitHub Actions or in GitHub workflows are individual tasks or actions that make up a job. So these are executed sequentially within a job's runner environment. Steps can include commands, actions, or scripts, allowing you to automate specific actions like building, testing, or deploying code as part of your CI/CD process. So in this example, we have 4 steps. The first step uses an action named checkout of tag v3 to check out the repository to the runner. Remember the term action. I will talk about it at the end of this session. The second step also uses an action to install Node.js on the runner, which provides node and npm commands in the runner path. And the third step uses a run keyword to execute shell commands on the runner. In this case, it is using npm to install dependencies. And the last step again uses a run keyword to execute the npm test command. And all the steps are executed sequentially. So what are these actions? So actions within GitHub workflows are pre-built, reusable automation components designed for a specific task. These actions can be created by you or by members of the community, making it easy to share and reuse automation logic across the repositories. Actions also facilitate integration with third-party tools and services, therefore enhancing your project's automation capabilities. So a few examples of official GitHub actions include the build and push Docker images. So this is a GitHub action which is used for building and pushing images to multiple Docker registries. We also have a create AKS cluster action, which is used for creating AKS clusters. We also have something called as vault secrets, which is a GitHub action allowing you to consume HashiCorp vault secrets as secure environment variables. Let's go ahead and create and run our first GitHub Actions workflow. So we have to create a new repository, or you can also do this in an existing repository as well. So let's go ahead and create a new one. Let me name this Actions-1. And I want this to be a public repository. So we will be using the public repositories throughout this training. Let me add a README file and create the repository. So this is a very basic repository which has a standard README file. So let's go ahead to the Visual Studio Code. So I'll be simply editing the URL from github.com to github.dev. It's going to open a developer code editor, which is based out of Visual Studio Code. So let's give it a few seconds. It's going to initialize and set it up. Okay. So ideally speaking, you can edit any files, you can push the files, you can pull them, and you can make changes like you do it in your Visual Studio Code. Okay. And before I proceed, I also want to install a plugin. So I just want to install the GitHub Actions plugin. So in the marketplace, we can simply search for GitHub Actions, and you can go through the documentation. So it's going to, help you manage your workflows, view the workflows, and it's also going to help you, automatically fill and provide you some, error messages whenever you make any mistakes in the GitHub Action workflows. So once it is installed, so in order to create our very first workflow, you need to create the workflow YAML file within a .github/workflows directory. And here I've just added some notes to the README file. So let me create a new folder, .github/workflows. So I just created these two folders, and within the workflows folder, you need to create your workflow YAML files. So let me create the first example. So let me just name the file as first example.yml. And here, as soon as you type this, if you say it's giving you some errors or some problems, right? So let me show you the problem. So let me toggle this point. So in the problems, it's saying that, it requires a mapping or a sequence. So this is because we installed the GitHub Actions, plugin from the marketplace. So it is going to, validate whatever YAML specification which we defined with the GitHub Actions YAML spec. Okay. So the first thing is I just want to give a unique name to this workflow. So the name of the workflow, let me just use, right? So this name is used to display the name of this workflow under the Actions tab. Okay, so if you don't provide this name under the Actions tab within the repository, it's going to show you the relative path of this YAML file. And then it also requires a trigger. So we can mention a trigger using the on syntax. And if it is a single trigger, so I can say simple push. So whenever I push anything to this repository, this workflow will be executed. You can also give multiple events over here. So if it is multiple events, we can use an array. And there are many different filtering options available. So we will, look at them as we move forward in this training. And after that, let me define a job. So you can define multiple jobs. So I'm just going to go with a single job for the time being. And each job, you can also give it a unique name. So I'm just going to name this as a first job. Let me just minimize this. Okay. So in this job, you need to define where the job runs, right? So you need to use, and if you simply click on Control plus spacebar, it's going to, display the syntax, which is, possible at this point of time. So I want to run this. So you have, multiple options available. So I want to run this on the Ubuntu latest runner or a virtual machine. And then you need to define the steps. So you can again define n number of steps, and all the steps will be running in series. So let me define a first step. So each step can also have an optional name defining what the step does. So let me just give this a name. So let me just format this a bit. And you need to also use the run option or the syntax, which is used for executing the commands on the Ubuntu virtual machine. And since it is an Ubuntu virtual machine, you can use the most widely available Ubuntu, CLI over here. So let me just use a echo command and type in some data. And you can, as I mentioned, so you can also give multiple steps. Okay, so the second step, I just want to list the files which are available in this repository. So currently we only have one README file. So I can use run and I can use ls, list files. And the third step, I want to read the file. Okay, so let me use run, and I can use the cat command, and I can use readme.md, right? So if you see, after you type all the things in the problems tab, you don't see any problems because we have not made any mistake in the workflow YAML file. So once you're comfortable or once you're ready with your workflow YAML file, you can go ahead and push this. So I'm going to use this option over here. So let me add a commit message as first workflow, and I want to just commit and push this. Okay, so as soon as you commit and push this, since we are using on as push in the workflow, it is going to run the workflow automatically for us. So in order to check this workflow, you need to go to your Git repository. So let me copy this endpoint. Instead of dev, I just want to use .com in the URL so that it shows me the repository. And in this repository, if you see, we have this actions tab. So in this actions tab, it's going to show you the action output or whatever workflow which is getting executed. And by default, if you see, if you don't have any workflow set up in the repository, you can also configure it automatically. So based on the project structure which is there in the GitHub repository, you can, if it is a Node.js application which you want to deploy to Azure Web Apps, you can use the out-of-the-box available workflow. You can just configure this, check out the default workflow, make some changes, and use the workflow, for deploying your applications. So similarly, you have a lot of out-of-the-box workflows available. So you can just check them out and use them as per your requirement. Okay. So for the time being, let me just push my first workflow which I have created. So let me just commit and push them. So once it is committed, if I refresh this actions page, okay, I guess it's not yet picked up. Okay, so I can see the changes over here. And I can also see orange dot over here, which is nothing but the workflow is in action. So let me go to actions. And this is the workflow tab or page, which we will be, exploring for the next few days. So here you can see that you can see the name of the workflow which I have given in the YAML file. Okay, it also shows you like how many workflows have been run, what is the status of it, when it was run, and on which branch it was run. So currently we ran this on the main branch. Okay, and if you see here, our very first workflow has failed. Okay, so let's see why this got failed. Okay, so let me go here. And here it's going to, show you a few more details about the workflow, like what is the total duration it took, why it failed. So it took 2 seconds for the job to run. So let's go to the first job. And you can see that, all the steps have been executed. So we had 3 steps: welcome message, list files, read files. Apart from these 3 steps, before executing our steps, it's going to set up the job. And after executing all the steps, it has the complete job. So these jobs run, automatically. Okay. So if you see the setup job, so there are various things which are happening here. So currently, this is running on a GitHub hosted runner. So the runner version is 2.309.0. It's also going to show you which operating system was used. Since we used an Ubuntu latest OS, so it's going to show you the version of the Ubuntu virtual machine or the operating system which was used. It's also going to, show you the details of the runner which was used. Okay, so it's also going to give you a URL which, gives you a detailed description about what were the included softwares on this specific runner. Okay, so if you go to this page, it gives you all the details like what is the software which is pre-installed on this virtual machine. Okay, and it also talks about the image release. Apart from that, it also uses a GitHub token. So this GitHub token is automatically created when you run the action, and it is used on behalf of you to access the GitHub account. Okay, so by default, it only has the read permissions enabled. So if you want to write anything, delete or update anything, so you need to appropriately change the GitHub token permissions within your workflow. And we will be exploring them in the later sessions. Apart from that, it uses the secrets which are defined in the actions space in the repositories. Currently, it does not use any secrets. And a few more steps over here. And then it's going to execute our steps. So the first step is it's just going to echo the line which I've mentioned or the message which I mentioned in the workflow. And the second step, it's trying to list the files. It's going to run ls, but it could not list any files. And the third step, it is failing in the third step where I'm trying to read the README file using the cat CLI command. So it's saying that no such file or directory has been found, and hence it gave an exit code as 1, which determines that the workflow has failed. Okay, so this is the default behavior. If the workflow encounters exit code 1 in any of the steps or jobs, it's going to treat the job as a failure. And the reason why it could not list any files or read any file available in the repositories, so this virtual machine runs external to the GitHub repository, and hence it does not have access to this repository, ideally speaking, like the README file, this README file or any files in this repository. So you need to explicitly, allow the workflow to download the repository in order to access the files and in order to, work with the files. Let's talk about actions. As mentioned in one of our previous sessions, actions within GitHub workflows are pre-built, reusable automation components designed for specific tasks. And these actions can be created by you or by the members of the community, making it easy to share and reuse automation logic. So we can locate and explore actions within the GitHub Marketplace, which is the primary place to find GitHub Actions. And we have hundreds of actions which are created by GitHub and other community members. And actions bearing the tick badge indicate that GitHub has verified the creator of the action as a partner organization. Actions without tick badges are created by members of the community. While you can utilize these actions, it is advisable to thoroughly review the action source code to ensure it handles your repository's content and secrets as intended. For instance, you should confirm that secrets are not shared with unintended host or logged. So we'll talk about security considerations in a separate module, but just keep this in mind. And once you have decided on the action to use, the process of adding it to the workflow involves exploring the actions documentation page. And this documentation will provide you the details about the action versions and the required workflow syntaxes. So how do you define the actions version, within your workflows? So it can be done in 3 ways. So you can use tags, branches, or shars. So tags are useful, for deciding when to switch between major and minor versions. For example, you can use an action tagged as version 3.6.0. Specifying branch for the action means it will always run the version currently on that branch. This approach can create problems if an update to the branch includes breaking changes. So this example uses an action which targets the main branch. And finally, for more dependable versions, we can make use of the SHA value, which is associated with the action version is recommended. So SHAs are immutable, so making them a more reliable choice compared to tags or branches. In this session, we will configure the checkout action within our workflow. So here we're going to add another step in order to read or check out our GitHub repository. So to do so, we will make use of an action. So actions can be filtered and checked in a marketplace. So you can simply go to GitHub Marketplace. And here it has the applications and actions. So we can click on actions. And it's going to show you around 20,000 actions. So these are the actions which are created by GitHub and GitHub partners as well as any user. Okay, so let us filter and check the checkout action. So here if you see, this is the checkout action which we want to use. If you see, it is created by actions, which is maintained by GitHub itself. And since this is maintained by GitHub, it also has the tick mark where the creator was verified by GitHub. But whereas the other actions, if you see, you don't have the verified option because those are created by private users, right? So let me just go and see the documentation of this action. So currently this action is using the V4 release. You can check out the documentation about what this action does and how to use it. It also gives you a sample workflow syntax on how to use this. The syntax is actions, which is the repository thing, and the name of the action along with the release tag. Okay. And with this action, we can also pass in some optional parameters, but we'll just use the users tag. Okay. And if you want to see the code of this action, you can also go to the Git repository. So this action is part of the actions organization or a team, you can say. And here it gives you the complete code or I think this uses JavaScript, which is used for, creating this action. Okay. And we can make use of V4, or we can also make use of the latest release tag, which is V4.1.0 as well. Okay. So let's go to our workflow. And before you want to play around with the files in the repository, you need to add a step before that step. Okay. So let me just add a new step. Let me just name this as checkout repo. And here, instead of run, I'll be using the users tag. Okay. So I think I didn't copy it. So let me go back. Let me just copy this syntax. Okay. I need to remove the users. So here, since we are making use of an action, you need to use the syntax users instead of run. And you can just give, the name of the action along with the release tag. So once this is done, let me quickly commit this. And let me simply push this. So once it is pushed, so you can go back to the Actions tab. You should see a new action is in execution state. So let me open this. So we only have one job in the action. So let's open this. And here it's running out all the steps. So if you see currently it's in the checkout repo, and yeah, it completed all the steps as well. So let's give it one more second. So now if you see, we don't have any error. The job was successfully completed. The workflow is successfully marked as completed. So let's check out some of the logs. So here within the setup job, so now we have an additional log message, which is downloading the action. So any actions which are defined in the workflow, so these are downloaded first to the runner and then the steps are executed. Okay. So, using this action, it checked out the repository. And here, if you do this ls, so it can, show you the README file. So it won't show you the .github repository, .github/workflow folder, because that is a hidden folder. So if you use ls-a, it would show you the hidden folders as well. And since now the repository is accessible to the runner, so it can also read the README file, right? So it's just going to, display the README file over here. And it has some post checkout repository. So some of the actions also have the post action as well. So once all the steps and jobs are completed, it's going to do the cleanup as well. Okay, so this is how you can make use of actions to do certain stuff. So if I go back, right, so now we have run two workflows. So the first one failed, but the second one was successful. So whatever logs which I've seen so far, so these are the generic logs. So if you want to see the raw logs of it, so you can simply, let me see. So you can download the log archive. You can view the raw logs, or you can also, view the timestamps of all the steps. So if I click on show timestamps, it's just going to show you the timestamp of when the step was executed at what time. Okay. And if you want to check out the raw logs, you can simply click on View Raw Logs. It's going to open a new tab and it's going to give you the raw logs as well. In this demo, we will see how to execute a third-party library and also run multiple commands using a single step. So if we go back to our workflow, earlier we made use of 4 steps. So let us now use a single step to execute these 3 commands. So here you can write all the commands one by one. So I'll just use ls-ltra. Instead of a simple ls, I'm using ls, and I also want to get the hidden folders. And then I also want to use cat readme.md. Okay, so if you do this, it might not work. So since this is YAML specification, you need to use a pipe. So once you use a pipe, all these commands will be executed in series, right? So we can remove these steps or just comment them out. Since it is YAML, you can use a simple * or a hash to comment out the steps. Okay, and let me also rename this. So instead of welcome message, I would like to use a different name. So list and read files. So the name field is an optional thing. It's used to easily identify the step. Okay, so apart from this, I also want to add another step to execute a third-party library. So here I want to generate some ASCII content. So let me name this step as generate ASCII artwork. And for the run command, I'm just going to paste the command over here. So I want to use the Cause library. So the Cause is a third-party library which is used for generating ASCII artwork, and it's going to display a cow with a message. You can also change the animal by using a -f. So I'm just using it to display a dragon with some custom message. Okay, and I'm also going to save this to a file as well. The name of the file is dragon.txt. So once you're done with this, so let me just quickly save this. I'll just add a commit message. And let me commit it. So once committed, I can go and check out in the Actions tab. So I should see a new workflow is in execution state. So let me go here. I still have a single job. So let's check the single job. And as you can see here, the job has failed. Okay, so before I go and check the failed step, so let us check the second step, which is list and read files. So here, as you can see here, so all the commands are executed in sequence. So first it executed the echo command, then it executed the ls-ltra command. So it can see that it displays even the .github folder. And then it also, displays the readme file, right? So whatever content we have, it just, outputs the content. And finally, the last step is the generate ASCII artwork. So this step, we were using the Cause command and it failed. The reason it failed is, if you see here, it could not find the command or the CLI. So the CLI Cause is not pre-installed on this Ubuntu virtual machine, and hence it could not run this. So any third-party library which is not installed in this Ubuntu virtual machine, you need to manually insert another step to install the library and then use it. In this session, we will go ahead and create a new workflow to generate the ASCII artwork. So here, instead of doing the ASCII artwork generation in the same workflow, we'll create a new one. So let me click on Workflows, create a new file. So let me name this as, okay, let me use smaller case, generate ASCII.yaml. So the name of the workflow could be anything. So I'm just using as generate ASCII.yaml. And here, I just want to copy paste the entire job instead of typing all this 26 lines. So let me quickly go through the content. So the name of the workflow is generate ASCII artwork. It's going to execute whenever I push to this repository. It has a single job named ASCII_job. It runs on Ubuntu latest virtual machine, and it has few steps. The first step, it's going to check out the repository. And in the second step, we are installing the cowsave program. If you remember earlier, when I tried to execute the cowsave CLI command, it returned an error message saying that the cowsave command could not be found. So for any library or program which you want to use in this Ubuntu virtual machine, you need to install them if it is not available as part of the pre-installed, software list. Okay. So I'm just using a command to install the cowsave CLI. Then I'm using a step to execute the command and generate some text and save the text in a file called as dragon.txt. And in the next step, I'm just testing if the file exists using the grep command. And then I'm going to read the file, and I'm just going to, check out the repository files. So here I'm just going to use -ltra. So let me just replace this with list repo files. Okay, I just want to list all the files which we have in this repository. Okay, so these are the steps which I have defined. So let me quickly publish this or push it. Okay. Okay, so let me just commit and push it. So as soon as you push this, so we can go and check the actions. So in the actions, so you can see that two workflows are executing as of now. So why are these two workflows executing? And if you see here, this is the my first workflow is getting executed, as well as the generate ASCII artwork workflow. So if you remember, under the .github/workflows directory, I have two workflows, and both the workflows run on push command, right? So whenever a push happens to this repository, so both the workflows will be executed, right? So here, since I made a change or I created a new workflow, and since both of them are on push, so both the workflows will be executed. And as you can see, my first workflow is failed because it could not find the cowsave command. But this generate ASCII artwork workflow is successful because we installed the cowsave CLI before executing the command. So let me go to this job. And if you see, all the steps were successfully completed. So first, it is installing the cowsave CLI using the apt-get install command. It also shows you all the logs over here. And then it's going to run the command, and it's going to save the output to the dragon.txt file. So using grep is also successful. It found the file and the term within the text file. I can do a read file if I do cat dragon.txt. So this is the output, which is generated by the cowsave command. And if I list the repo files, I should see the readme files, .github, .git, and also the dragon.txt. Okay. And finally, you have the post checkout repo and the complete job. So here, whatever dragon.txt file you're seeing here, so this file is generated in this Ubuntu virtual machine. And once the virtual machine completes all the steps and the virtual machine gets closed, the file is also deleted. Any files which are generated or created during the workflow execution are automatically deleted when the virtual machine closes, right? So if you let me just scroll up, go to the code base, you don't see any dragon.txt file, right? So that file is not persisted in your repository. It's only available on the virtual machine, and when the virtual machine terminates, the files are also deleted, any files which are generated. Okay, so that is one point which you need to remember. And the other point here is, so if you have let me go back to the workflows. So these are the two workflows which you have. So if you have 10 workflows and all the 10 workflows listen on a push event, so all the 10 workflows will be executed whenever a push event is seen in this repository. So in some cases, you want to disable some old workflows which are not used currently, right? So you can also disable workflows. So let's say I want to disable my first workflow. I don't want to use it anymore, right? So what I can do here is, so I can click on my first workflow on the left side. It shows me all the workflows which were executed for this specific workflow. Similarly, you can also see for the generate ASCII workflow, only one workflow was executed, right? So for any workflow, if you want to disable it, you can click on it. You can just disable. You can click on this disable workflow, and this workflow is manually disabled. So now whenever there is a push event, this workflow will not be executed. Only the generate ASCII at work workflow will be executed. In this session, let's see how to execute shell scripts within a workflow. So you can execute any shell script in a workflow using a step and a run command. So for this example, I want to execute all these commands using a single shell script. So let's first create a shell script within our repository. So in the repository, let me create a new file named ASCII-script.sh. And let me just paste in the same commands which I have used in the workflow. So let me just use ls-ltrarray just for demo purpose. And how do I execute this shell script in the workflow? So within the workflow, I can remove all these fields. Let me name this step as executing shell script. Okay, and you just need to give the path of the shell script. So shell script.sh. Okay, and I just want to use this file on top of this. Okay, so I just want to list the files within the repository. Okay, so that's it. Let me just push this, commit and push. And let's go ahead and see the workflow in action. So here, if I go to all workflows, you can see that only one workflow is executing now. The my first workflow will not be executed because we have disabled it. Okay, so now here in the executing shell script, so let's go this. And here you can see that the job has failed. So let's see why the job has failed. And here it's going to give you an annotation like what error occurred. If you want to check out all the logs, you need to go to the job. Okay, so here the error is saying that processing completed with exit code 126. So let's go to the job. And we see that there is an error in the executing shell script step. So here the log is, it is getting permission denied to run the shell script, right? So how do we bypass this? So you need to go back to the workflow, and here you need to add permissions. So I'm going to add a pipe, and before executing this shell script, I just want to use chmod and make the file executable. Okay, so let me just use the name of the file and paste it. Okay, so let me just add some commit message. And let me just push this. Okay, so once you push it, it's going to start another workflow. And here before this step, if you see the list repo files, and you can also see this ASCII script.sh file, and you can see that in the permissions, it does not have the executing permissions, right? And that's the reason, it failed. So, but now I have added the permissions within the same step, so it should be able to execute it. So let's go back and see a new job or a new workflow is getting executed. So let's go to this, open this, right? So it is in the executing shell script stage. So let's wait for a few seconds. As you can see here, it is installing the Causa CLI prompt, and it has also executed all the other, I think, steps which you have defined in the shell script. So if I open this, so you can see that first it has installed the CLI, then it executed the command, and it did the grep, then it's reading the file, and it's just outputting all the file content. All right. So if you want to see the commands over here, I think you can't see the commands. Let me try to expand this. No, it just shows you the command which was mentioned in the workflow, right? So these are the two commands which were executed for this step. But yeah, so after you added the permissions, you can see that, the workflow was successfully executed. So this is how you can execute shell scripts within your workflows. So far, we have only explored a workflow with a single job. In this session, we'll talk about how you can use multiple jobs within a workflow. So if we go back to our workflow, which we have been using for the past couple of demos, so if you see here, we only have a single job, which is doing a lot of steps. So what I want to do here is, I want to remove this and add multiple jobs. So let me just copy paste the code to save some time and format it a bit, right? So let me explain the code which I have pasted. So here I've added 3 new jobs. So generally speaking, in a CI/CD pipeline, you have the build phase followed by the test and then the deploy phase. So let's assume each of these phases we want to use separate jobs. So that's the reason I created 3 new jobs. So just for naming convention, I'm using build_job1, test job2, and deploy job3. So let's see what is happening in each of these jobs. So first, let me expand the build job. So within the build job, I'm using a runs on syntax, which defines on which machine this build is going to happen on. So I just defined, I want this job to run on the Ubuntu latest machine. And then in the steps, I want to, install the Causa CLI, execute the command, store the output in a file, and just sleep for 30 seconds. Okay. In test job, I want to run this job on the same Ubuntu machine. So here, each job needs to run on its own machine. So both build and the test job run on 2 different machines, and both the machines are using the Ubuntu latest operating system. You could use Windows or macOS for testing and a different operating system for build phase. It depends on the use case. But the main point to understand here is each job runs in its own virtual machine. They don't run on the same virtual machine. Okay. So the test job, I'm just using a sleep command to sleep for 10 seconds and then test the file which was built in the build job and see if there is any word dragon available in this, text file. So that is the test I'm doing here just for demo purpose. And finally, I have the deploy job. In the deploy job, again, you need to mention where this job needs to run, the machine. So I'm just using Ubuntu operating system for this job as well. And here, I just want to, read the file and do some deployment. So this is not an actual example. So I'm just going to do some echo deploying. Okay. So if you see here, we are creating a dragon.txt file in the build phase, and we want to test it in the test job, as well as we want to, display the content of it in the deploy job. Okay. So these are the 3 jobs which I've created. So let's commit it and see how the workflow gets executed. So let me just add a commit. So it's just going to be added multi-jobs. And let me just commit this. I hope there are no errors, because if you see, you don't see any problems detected in this workflow. Okay. So if I go back to the workflow, okay, I think I have not pushed it. Okay, let me commit and push. So this should trigger a new workflow execution, added multiple jobs. And here you can see that we have 3 separate jobs. And as you can see here, these 3 jobs will be running in parallel by default. So that is the default behavior. So if you have 10 jobs defined in your workspace, all the 10 jobs will be running in parallel and they do not wait for any other jobs. And that is the default behavior in GitHub Actions. So here, if you see here, the first job which was executed was the deploy job, which was then followed by test job, and build job is still in progress. So ideally speaking, we want the build job to be executed first, and then the test job, and then the deploy job. But that's not the case in the default scenario. In the default scenario, all these steps or jobs will be executed in parallel. And as you can see here, only one job was successful. The rest of the jobs failed, so the entire workflow status will be in failure state. Okay, so in order for the workflow to be successful, all the jobs should be in successful state. Okay, so let's understand why the other two jobs failed. Okay, so if you go to the build job, of course, it installed the Causa CLI, it executed the command, it created the file, and it was sleeping for 30 seconds. In the second job, we were trying to test the dragon.txt file, and this job ran before the build job. And ideally speaking, this file should not be accessible in the second job. The reason is, since these jobs are running in parallel on different virtual machines, whatever files which are created in the build job will not be available in the test or the deploy job, right? So here we have two issues. The first issue is the jobs are getting executed in parallel. We need to execute them in sequence one after the other. So that is the first issue. And the second issue is whatever files which are created in one job cannot be accessible in other jobs. In this session, we're going to use a needs syntax to run multiple jobs in sequence. So let's go to our workflow, and we want to run the test job after the build job, and we want to run the deploy job after the test job. So how do we do that? So we can make use of the need syntax, and this syntax has to be given at the job level. So here you can just give needs, and if you want to know more information about what this syntax does, you can just hover your mouse on top of needs, and if you have installed the GitHub Actions plugin in this Visual Studio Code editor, it's going to give you a description about this specific syntax. And it says that it is used to identify any jobs that must complete successfully before this job will run. And it accepts string and also array as well. So here, you can simply, do control space. It's going to show you the names of the other jobs available in this workspace. You can simply select, the name which you want to use. Okay, so now it means that this job will be executed after the first build job is successfully done. And you can also do other validations as well. So here, if you go to build job, and if you use needs, and if you try to use the same name, like the name of the job, it's going to say that this is a not valid needs. The reason is this is going to create an infinite loop, or it creates a cycle in the dependency graph, and hence the GitHub Actions by default does not allow such values, right? So it's not logical, right? So this is one thing which is good. It's kind of a validation which occurs even before you publish the job. Okay, so that is one step. And the other step is if you try to use test job, and again this is like infinite loop. The build job needs the test job, whereas the test job needs the build job. It's like again infinite loop, or it creates a cycle, and it is not allowed in GitHub Actions. So these validations are useful before you even push the code. Okay, so let me just remove that. And in the deploy phase, I want to use another needs. And if I want to use an array, I can also use an array. And within the array, I can also mention multiple jobs. If this job depends upon multiple jobs, you can define an array as well. Okay, but for the time being, I only want the deploy job to wait for the test job. Okay, so this is how you can define the needs keyword. So let me just commit this. You can call it as a keyword or a syntax. So let me quickly commit this. Okay. And I forgot to change the sleep command, but yeah, that's fine. So let me go back here. So a new workflow is in execution state. It's currently queued, if you see. So it's waiting for a worker. And once it finds the worker, the status changed to in progress, or the machine, I mean to say. So if I go here, now you can see that this graph has changed, right? So here you can also, it also shows you the dependencies. The test job is now dependent on the build job, and the deploy job is dependent on the test job, right? So this graph gets auto-generated based on the workflow configuration. Okay, so now the test job and the deploy job are not yet started. Okay, it's waiting for the build job to complete. So let's see the build job. So the job is completed. As soon as the build job is successfully completed, the test job will begin. So let's wait for the test job. So it's going to run a new virtual machine, and within the virtual machine, it's going to execute all the steps defined in the test job. And you can see here, the test job has failed. And since the test job is failed, which is, mandatory for the deploy job, so the deploy job will automatically be skipped. If you see here, this will not be executed because the deploy job depends on the test job. So here, if you see to the deploy job, this is automatically skipped. Okay, it won't be executed because the previous job, which is dependent, is failed. So let's see why the test job failed. So the test job failed because it could not find the file, the dragon.txt file, right? So in this session, we made sure that the jobs are running in sequence one after the other using the needs keyword, but whatever files which were created in the build job are still not accessible to the other jobs because all the three jobs are running on three different machines, and automatically the files are not shared between them. In this session, we will have a look at how to upload artifacts from one job and download the artifacts in another job. So let's go to our workflow. So here, we want to basically upload whatever dragon.txt file which is getting generated in the build job, and then download the same file in both test and the deploy jobs. So to do that, we have a couple of actions already available. So we can quickly go to GitHub Actions Marketplace. So within the marketplace, you can see that we have two options here: upload build artifact and download build artifact. So let me open both of them in separate tabs. So this upload artifact is used, or it allows you to share the data between jobs and also store the data once a workflow is completed. And to do so, you can simply use this syntax. So this is the syntax which is used for making use of this action. You can give the artifact a unique name so that you can also download the artifact, and you need to give the path of the artifact which needs to be uploaded. Okay, so once you upload it, if you want to download it in another job, you need to use the download artifact action. This basically downloads the artifact which was uploaded in the previous jobs. And again, the syntax is a bit similar. You need to use action/download artifacts. Okay, so let me copy this syntax. Let's go to our workflow. So in the build job, so let me remove this sleep. I don't need this sleep anymore. I just use this for demo purposes. So I want to add a new step which is going to upload the dragon text file. Okay, and here instead of run, I want to use the action. So I just need to remove this. Let me paste in the action, format this a bit. Okay. Okay, so here I'm using uses action upload artifact @v3. So what is the name? So I want to give it a unique name so that I can download it using this name. So the name here, I want to use this as dragon text file. You can use any name. And what is the path? So this is saved on the root path. So I'm just going to use dragon.txt. So this is going to upload. So how do I download the same file in the test and the deploy jobs? So what I can do is I'll just copy the same step over here. I don't want the slip command here, so let me paste it. Okay, so here I want to download. So let me rename few of these things. Download the Dragon text file. And what is the action name? So let me go to the download build action. So I think it is simple download. Okay, let me go back. So let me modify this to download artifact v3. And I don't need to give the path. I can simply give the name of the file which I want to download. And that's it. So after this, I'll just copy the same thing and paste it in the deploy job as well. So before you read it, I want to download. So let me paste this. That's it, right? So I've added 2 download actions for the test and deploy job and an upload action in the build job. Okay. Okay, so let me commit and push this. Let's go to the actions. A new action has been, our workflow has been started executing. So let's go to the build job. It is still setting up the job. So let's see what it set up. So here, if you see here, it is also downloading an action, which is the upload artifact. Okay, so since we have mentioned this action within this job, so it will download the upload artifact action on this Ubuntu virtual machine, and it's going to, create the file dragon.txt, and it's going to upload. So if you see the logs of this upload, so it provides you a lot of logs. It also shows you that, the size of the file was around 1000 bytes and few more details. Okay, so finally, the thing which I'm looking for is the artifact dragon text file has been successfully uploaded. Okay, and it completes the job. Okay, so now the file has been successfully uploaded. Okay, so if you see here, the other jobs are also successful in this scenario. So let's go back to the summary of this page or this job. You can see that both the jobs are successful because it was able to access the file. So let's go to the test job. In the setup job, it's going to download the download artifact action. And in the download step, you can see that, it is downloading the name of, the file, which is having this name which we have mentioned here. Okay, so it downloaded the action, and it's also going to show you the runner where it got downloaded. And the last log message says that, the artifact has been successfully downloaded. And it also shows you how many files were downloaded. In our case, it's only one. Since the file was downloaded, the grep command testing was successful. And similarly, in the deploy job, it's again going to download the Dragon text file. It's going to read the file. Since the file was downloaded, it's able to read the file, and hence all the 3 jobs were successful. Okay, so this is how you can upload and download artifacts across multiple jobs. Okay, so here I'm just using a text file, as an upload file. But in real-time scenarios, it could be a Java application. When you build a Java application, most probably you will be getting a jar file or a var file. So you can, upload the, jar file so that it can be tested and deployed in other jobs. And one more advantage of using this upload artifact is it is also going to store the artifact on GitHub. So once the virtual machine is terminated, the files are also terminated, if you remember. But since I'm using the upload artifact, so this artifact will be available for download. So this is produced during the runtime. So this file can also be downloaded by the users. Okay, so if I want to download this file, right? So this file is downloaded. I'm not sure where it got downloaded. Only see a simple dragon.txt file. So let me open this. It's going to take some time. I think my notepad is not in open state. So let's give it a few seconds. Okay, so as you can see here, this is a file which got downloaded, and this file by default will be stored for 90 days. So that is the default time period. So if you want, you can also change this time period. You can go to settings of this repository. In the settings, you can go to actions on the left side and click on general tab. So we'll be exploring the permissions at a later video, but here you can see that the artifact and the log retention period is 90 days by default. You can also, change this. And for this organization, the maximum limit is 90 days because this is a free account. And also the size of the artifact is just few bytes in our case, but the maximum allowed size is 500 MB in the free accounts. So let's check out how we can make use of environment variables within a GitHub action workflow. So here, to save some time, I've already created a new workflow named as variable-secrets.yaml. The name of this workflow is exploring variables and secrets. And this workflow will be executed whenever we push an event to this repository. So let me quickly explain you the jobs. So we have two jobs. So we have a Docker job and a deploy job. So both the jobs run on Ubuntu latest virtual machine, and the deploy job is dependent on the Docker job. So this will run after the Docker job is successfully completed. So in the Docker job, we have 3 steps. So these steps are basically used for building a Docker image, logging into Docker, and also pushing the Docker image, which was built in step 1. So if you see in these 3 commands, we are making use of Docker.io, which is the container registry, Docker username, image name. And if you see, the Docker username is used in 4 different places, even in the deploy job where we are going to run the image. And we also make use of the image name and the container registry name in multiple places. So in workflows, we have an option to store environment variables, which could be like for non-sensitive configuration values like, username, or it could be some flags, or, it could be, a few other values which are used for the application, right? So in this case, the environment variables can be stored in 3 different places. So it could be stored at the step level, job level, and at the workflow level, okay? So let us create environment variables and use them at the step level, okay? So I already have the code for that. So let me just delete this and uncomment environment variables at the step level. So here, this example talks about how to use environment variables at the step level, okay? So we have the same 2 jobs, and we have the same commands. The only difference here is, so I am making use of environment variables at the step level. So if you see, each step has its own environment variables defined. So the syntax is env, and you need to give a key value, expression. So here the key is container registry, and the value is Docker.io. Similarly, all the environment, variables can be defined in such a way. Once we define the environment variables, so how do we refer them in the commands? So here we have 2 options. So you can use a simple $ symbol followed by the key of the environment variable which you have defined at the step level, and that follows for all the variables, $ and the key of the environment variable. And the other option is you can also use $ curly braces env dot. It's going to display all the environment variables at the step level. So you can select which one you want to use and close the brackets. So this is another way of referring the environment variables. You can either use this notation or a simple $ notation as well. Okay, so the same thing has been done in all the steps. And if you notice, in step 2, we are also using environment variables for storing a sensitive value such as a password. So generally speaking, variables like password, API keys, tokens are sensitive in nature, and it should not be hard-coded in the workflows. So you need to make use of the secrets. So we'll talk about secrets in the next session. So till then, we'll just hard-code the secret in the workflow itself. Okay. So this is how you define environment variables at the step level, right? So even in the deploy job, I have defined it at the step level. Okay. So if you see here, this works perfectly fine without any issues. But if you see here, we are repeating the same environment variables in multiple places, right? So ideally speaking, in software, we always try to follow the DRY principle, which is do not repeat yourself, right? So in order to reuse environments, so we can also define the environments at the job level instead of the step level, okay? So in the next example, which I have commented out, so I will be making use of the same environment variables, but at the job level instead of, defining them in each and every step. So let me delete this as well. Okay. So now the next example is the environment variables are defined at the job level. So let me uncomment the example. So here again, we are making use of the same example, which has two jobs. But if you see here, we defined the environments at the job level, not in each and every step. So any environment variables defined at the job level will be accessible to all the steps within that job. So in this Docker job, we have 3 steps. So this environment variables will be accessible to all the 3 steps. Okay, so any environment variable you define here will not be accessible in other jobs. It will only be accessible in this specific job. And finally, here you can see that the Docker password environment variable is only specific to the second step. So you don't need to use this at the job level. Okay, and similarly, in the deploy stage, again, I'm using job level environment variables, which are used in the Docker run command. So these are the 2 types. So we have seen how to use environment variables at the step level and at the job level. But here, you still see that the same environment variables which are defined at the job level are repeating. So the final example which I want to show is using environment variables at the workflow level. So what I can do is, I can delete the environment variables at the job level. Okay, so let me just get this. And you don't see any errors for the time being because we are just using the dollar notation. So if you use the $env notation, curly braces env.container registry, it's going to give you a warning. So if you see here, it's highlighted using yellow, underline over here. So if you see the problems at the bottom, it says that, it does not have context about this container registry because we have not defined this environment variables in this workflow. It is not an error, but it is treated as a warning. Okay. So let us define this environment variables at the workflow level. So if you want to define it at the workflow level, you need to define it at the root. So let me just paste this. Okay, so once you define this, you see that the warning is resolved because now it can access this variable from the workflow level. So whatever variables which we define at the workflow level will be accessible to all the jobs within the workflow. Since we have 2 jobs, so this environment variables will be accessible to both the jobs. Okay, so let's quickly commit this and see it in action. Added variables is the commit message, and let me push this. Okay, so let's go and check. We should have a new workflow which is exploring variables and secrets, and a new workflow is getting executed. So here we have 2 jobs, Docker and deploy. Deploy depends on the Docker workflow or the job. So we made use of the needs syntax. So if you go to Docker and if you see the job, okay, it has some options over here. If you go to Docker build, you can see this command. We are using echo commands. We are not running Docker commands as of now. We are just using echo to check out the Docker commands. So here, if you see the Docker username is okay, I think Siddharth one, which is correctly replaced, and the image name is GitHub Actions Nginx. So it is also correctly replaced. So if you expand this command, it will also show you like what are the environment variables which are accessible for this step. Similarly, for Docker login, you can see that the username is printed, but for the password, it is using # because password is a sensitive field. But again, if you expand this command, you can see that the Docker password is an environment variable which is still accessible to this step. And whatever value you mention, it is in plain text and will also be logged in the logs. So any person who has access to the logs will be able to, get the, plain text password. Okay. So in the next session, we will also secure this using secrets. Okay. So this is the Docker job. If you go to the deploy job, which has access to the same environment variables, right? So you can see that the values are correctly replaced here. So we have the container registry values, Docker.io, the username, and the image name. If you expand this, you see that these are the same environment variables which are accessible for both the jobs. Okay, so this is how we make use of environment variables in workflows. In this session, let us understand how to store and use secrets at a repository level. So let's go to the workflow. And as you can see here, earlier we were making use of the Docker password and the value was in plain text. So this is not at all secure. So in order to securely store the sensitive value, you have multiple options. So we can store the secret at the organization level. So we can create organizations and you can store secrets and environment variables which will be used by all the workflows which are part of that organization, or you can use them at the repository level or at the environment level. In this session, we will explore repository level secrets. So let's go to settings of the project which we are using. In the settings, on the left side, you have the secrets and variables, and we want to work with the actions. So here, you can manage the secrets or you can store the secrets at the environment level and also at the repository level. So not only secrets, you can also store variables as well. So earlier, we were storing variables at the workflow level, and these variables cannot be used in other workflows. So if you want to use the same variables across different workflows in the same repository, we can define them at the repository level. And any secrets which we are storing here are encrypted and are generally used for sensitive data purpose. Okay, so let's add the Docker password as a secret over here. So let me create a new repository secret. And I can use any text because we are just echoing this, right? And let me add the secret, right? So now we added a Docker password repository level secret. You can also add a variable. So let me add a new repository variable. So let me name this as Docker, let's say username. Okay, so Docker username. Okay, and let me add the value. So the variables, the key and the value will be visible, but for the secrets, it is not visible. The value is not visible, basically. So after defining the secret, how do we use this in the workflow? So in the workflow, I can remove this Docker password environment variable, but how do I refer the secret? So the syntax here is, it is $, curly braces, double curly braces, secrets, dot the key value. and you need to also close this. So this is how we refer the secrets defined at the environment level, organization level, or at the repository level. Okay, so this is secrets.docker password. Okay, and we can also remove the Docker username because I think we are defining that in the environment variables, or sorry, the repository variables, so that will be used. Okay, so let me quickly commit this. Okay, it's not pushed. Okay, it's saying unable to commit. So let me see why. So let me try this once again. And yep, this is committed successfully. So let me go and check the new workflow execution. Okay, the Docker step is running currently. So let's check the logs. Yep, all the steps have been successfully completed. So if we go to the Docker login step where we made a change here, so here, so as you can see here, the password is accessible by the workflow and it is defined using hashtags, but the username is null or it's empty. Even if you go to the Docker publish step, you see the username field is empty. The reason why it's empty is, if you check out, we defined the Docker username as a repository variable. And in order to use repository variables within the workflows, the syntax is a bit different. And we are using Docker username variable in multiple steps. So you need to replace this. So let me copy this. So you need to replace this using vars. So in order to access the repository or the organization or the environment level variables, the syntax is vars.docker_username. Of course, this should be within the double curly braces. Okay. Let me replace all the 4 things. And you can see that, it's going to give you, warning. The reason is, these values are defined in the repository level variables and secrets, and the Visual Studio Code editor cannot get the context of the repository settings. And hence, it gives you a warning, which can be totally ignored. So let me quickly commit this. Okay, and push this. So let's go ahead and see the logs. So a new job is running here, modified variables. So let's go to the Docker job. And if I go to Docker login, so now I should be able to see the username, which was defined at the repository level. If I expand the command, it still shows you the environment variables defined at the workflow level, but you can see the username value was fetched from the repository level and used here. If you go to publish, you see the value being, replaced here, right? So this is how we can make use of repository level variables and secrets. That's all for now. Thank you.